Hello, good afternoon, and welcome to this latest episode of the MCC livestream series, where we are talking about Everyone Can Code from Apple. Let's get our introductions done first. With me, as always, is Mr. David Kirtland. David is an Apple professional learning specialist and is on location in a school somewhere in the north of England, I believe.
That's right.
So thanks for joining us, and thank you to the school for giving us some peace and quiet for half an hour while we do this. I'm Richard Child. I am the Education Manager for MCC Digital. We are an Apple Authorized Education Specialist. And over these last few webinars, we've been looking at the Everyone Can Code content from Apple, which is to support the teaching of computing and coding in classrooms. And we have been working through a few of the modules. We've looked at the teacher resources. And today, I think we're going to go a little bit deeper on functions, are we not?
That's right. Yeah, we dipped our toe in those last week with the MeBot when we were starting to get the robot dancing. But that had a nice kind of prescribed way of having a look at the introduction for it. Whereas now we're going to go back to Everyone Can Code and back into Swift and with Byte moving around his maps and really having a look at how these functions can help us optimize some of the code, make it a little bit shorter in the coding that we're going to put together.
Excellent. Take it away. Let's get optimizing.
So let's just remind ourselves of the resources. So back into the Everyone Can Code puzzles book. We're on chapter 2 now, which is functions. So again, we've got our aims for the section. So we're really going to look at what functions are and how we can start using those, start writing our own functions within the context of this code here. And we've got two key terms to look at. We've mentioned function already. We're going to have a look at what one of those is. And we're going to start using algorithms as well. Just use that terminology in the kind of the conversations that we're having. So again, just flicking through the lessons, we've looked at some of these, kind of the structure of these and what we're looking at. So we're learning that basic knowledge and we're starting to think about functions. We've got those nice little drawings there, which kind of makes some links to the Everyone Can Create curriculum, the drawing one there with those emojis. And we just want the children to think about how we can group tasks together and how those are what we really look at as a function when we come to coding. So we've got a nice little task there around origami, where obviously we fold in paper and we get multiple folds, which could create a certain thing. And we might use some of those folds and those patterns over and over again. And essentially, that's really just a function. It's just a repetitive task and action that we're going to use several times. And we're just making things a bit quicker by saying these are grouped together and maybe giving those a name so that we can use those as we're working through. So let's just skip through some of these lessons and we can see we've got our first example here. We've got Byte and we're moving around our map. And in those first few lessons, we did move left a lot. Kind of in that Doctor Who way, we always turn left, but sometimes we do need to turn right, but there is no command at the moment to turn right. So the children need to work out, and we'll see this in the lessons, that actually if we turn left 3 times on the spot, we are turning left, but 3 of them together result in the same outcome as turning right, which is facing that same direction. And we're going to use that as the basis of our first simple function. And we can look at the code here. Just looking at this post-it note example that's on the page here, the lower section there that starts with 3 move forwards, that's our main code. That's the type of thing we've been writing so far. But the first bit there is the syntax we have for a function, and it says func, short for function. The function here has been named turn right. So remember in that camel case, we've got that lowercase turn and a capital R on the second word, just to make it easier to read. And then within those curly brackets are the 3 turn lefts. So when we need to turn right, we don't have to write turn left, and turn left. We can now just call turn right, and it does that function for us. So just looking down that code, after the 3 move forwards, we have that turn right. And we just use that like any other command. Now we've done that header bit of information up at the top with the turn right function. So that's kind of how the coding will look once we start putting it together. And there's a really nice little graphic here about what a function is, just looking at a book. So if we look at the spine on a book, that has the book title. That's the name of our function. And then the front and back covers, that's just the wrapper that holds it all together. Those are those curly brackets. And the actual content of it are the pages in between. So just a nice little graphic there to represent how a function is constructed. Just a nice little way of presenting that information. So I'll leave you to look through those lesson materials in a bit more detail. Let's jump straight into Swift Playground and have a look at some of these lessons. So I'm here I'm in the second section here. We've already completed those commands ones in the first few sessions here. We're now looking at functions, and we're going to jump straight into composing a new behavior. So as always, there's Byte, and he's on his map, and he's got to go along here, and we're going to collect that gem. So there's nothing complicated about this, but we have got a turn right in there. So this is really for the children to start saying, let's put our code in, and I think we're going to move forward, and move forward. That will take us to the bottom of those steps. And then we do need to turn right. So we don't have a turn right, so we can turn left, left, and left, and then move forward, and move forward, and collect the gem. So that, even though we don't have a turn right, should have the same outcome. So let's just try it. Let's run the code, and let's just check, and let's walk through it. So we're moving forward, and we're going to turn left. So he's physically going to turn left, so he's facing the wrong way, but 3 of them in a row will have the same result as turning right. So there we go, and we've collected the gem. So really quite nice and simple and straightforward, but it is quite long code to achieve that. So let's move on. So creating a new function. So this time we want to define and use our own function. So we have our syntax down here. We've started giving us our headings here, function, and the function's been named for us. It says turn right, and let's have a look. We've got a more complicated map here. So we need to walk forward and go along. We can go down these stairs. We've got a button there. It's already on. That's fine. And we need to go down through the portal, come out of the other one. And the last thing we need to do is turn that other button on. So let's have a look. So we want to create our turn right function. So let's add our commands in here. And we already know that 3 lefts give the same effect as turning right. So that can be our turn right function. Nice and straightforward. So let's stand behind Byte and let's work out our main block of code now. So we've set our header. Let's put our code together. So we're going to move forward, and it will turn left onto that square. And then we need to turn right, don't we? So we're facing down the stairs. So we can call that function. So we don't need to bother with all those turn lefts. We just turn right straight away. In fact, actually, I need to delete that, don't I? And we need to put our code in right. So we are doing that debugging as we're going along. So I've moved forward, I've turned left. I need to move forward again first, don't I? So I'm on that kind of sandy square. And then we turn right and go down, move forward down the stairs onto that button. That's fine. And then we can turn right again and move forward. Should take us onto the portal. And we'll come up this portal here. So we'll be facing that way, the same direction. So let's turn right again. We'll move forward, turn left, move forward, and toggle the switch. And let's just check that we've got the code right. Let's run it and see what's happening. So we're moving forward, turn left, move forward, turn right with 3 lefts. So there we are, facing down the stairs. Move forward, turn right again, which is 3 more lefts. Through the portal. Let's turn right. There we go. And hopefully onto that last switch. And let's toggle it. There we go. So a bit more of a complicated map there. The children need to kind of work out the route and the way we're doing it. But in terms of the code, it's a bit more involved, but it's still fairly straightforward. But we have got our first function in there. So we're kind of getting to grips with this. Let's move on. So we want to collect, toggle, and repeat. Now let's have a look at this. So we've got a more complicated pattern here. So the key word in this is repeat. So we use functions to keep our code nice and short and optimized. So it's quite short code, but also quite quick and easy to run once we've got that function in there to repeat these patterns. So that means if we look at this, there must be some repeating patterns. So let's have a look at this in a bit more detail. Let's go and just pull this out to the full screen. And let's just have a look at the patterns we have here. I think I'll view it that way. There we go. And I'm going to just take a screenshot of this in the usual way. I'm using the buttons. With a screenshot, this is quite a nice way to work with the children, because part of the problem with this is that logic and the thinking of around solving these problems. So just using a highlighter pen, I'll use a red pen for the moment. We've got Byte here. We need to move forward and collect that gem there. We need to move forward again and toggle that switch. And we can probably move forward onto that square. And then if we might want to turn and face the right way. But once we stood there, look, if we move forward, we collect that gem, move forward, press the button, and we can move forward again. So that repeated pattern will solve most of that side as well. It doesn't quite go the full length, but let's think about it. Let's use a blue one this time. But again, once we've stood there, we can move forward, collect that gem, move forward, toggle that button, move forward onto that square. And we're nearly there, aren't we? Look, move move forward, collect the gem, move forward, toggle the switch. So that pattern, we can use it 3 times. We have a couple of bits in between just to make it link up, but the basic pattern we could use 4 times on this to keep our code nice and condensed. So let's get rid of that screenshot. You could save this, obviously. This is really nice to save and archive and let the children maybe upload it to something like Showbit or Google Classroom or Seesaw and add a little bit of context to this, saying what their thinking process was to go through and find these patterns and solve the solution here, find the solution. And we've got that evidence to go with us. So let's go back to our code and let's start putting our text together. So we need to give this name a function. So I'm going to call this, I think because we're collecting a gem and we're toggling the switch, I think I'm going to call it gem switch. And remember that camel case, so we're keeping it lowercase, but a capital S for that second word, switch, just to make it easier to read. And then let's put our code in. So we need to move forward. We can collect that gem. We can move forward, which should take us onto the switch. Let's toggle the switch. And let's move forward again. And that's that pattern we've just highlighted with those pens in the screenshot. And that'll take us to this n square. So let's put our code together. So the first thing we need to do is our gem switch, which is that function there, take us to that n square. Then I think we're going to need to turn left. And then we can just run that function one more time. This side is quite slightly longer, so let's just move forward again. Turn left so we're facing the right direction, then run our function one more time. And then we can turn left and the function again. And because we've got that code in our function, our actual main bit of the code now is only, what, 8 lines long? So it's nice and short code. It's nice and condensed there. Let's check it works. So let's run the code. So there we go. There's our first function, going and collecting the gem, toggling the switch, and moving forward. So that's our first function. Let's turn left and run the function again. There we go. So we've got that extra bit of code to get down the stairs because it's a longer distance that way. If it had been the same length, we could have just run the function 4 times and it would have more or less worked. And there we go. Our last switch to toggle. And we finished that problem. We solved that problem with that logic, and we've recognized the loops and the patterns and how we can repeat things here to work this together. So that's the hard part with this, being able to analyze a situation and find those repeated patterns, and then translating that into a function is fairly straightforward once we've worked out what the patterns could be. So let's have a look at the next one. So have a look at our problem. So we've got a grid of gems to collect. So we need to think, are there any patterns here? Well, let's have a look. And let's zoom in so we can see it. So let's take a quick screenshot. Now, there could be a few solutions to this. One of the nice things about code is there isn't always just one answer, and different children will come up with different solutions. So let's think about what we have here. So we stood on a square with a gem. So we could just go walk down here, collect that gem, collect that gem, and collect that gem. That is probably a simple pattern because we could do that facing the other direction and just move across for each of these routes here. We could probably find a more complicated pattern which involved turning around and facing the right direction. But I'll leave you to have a look at those, see whether you can come up with any more interesting looped patterns, repeated patterns for this, and see how we go. But I think I'm going to stick with that simple one for the moment. So let's press done, and let's go and have a look at putting some of our code in there. So let's give our function a name. I think we're collecting 3 gems, so should we call it triple gem? Remember, in our capitals. And let's have a look. So we stood on a square with a gem. So let's collect a gem. Let's move forward, collect the next gem, move forward, and collect the next gem. And that should take us down that pattern that we've just highlighted. 3 steps forward and 3 gems to collect. So let's put our code in. So let's have our triple gem. That starts off our first line. And then we need to turn right. We need to move forward. Turn right again so we're facing the right direction. Then we can run our function. So triple gem. And then this time I think we need to turn left. Move forward, turn left, and then run our function again. Let's have a look. Let's run that code. So there's our first version of the function. Let's do our joining little bits. And let's collect our 3 gems. There we go. And let's face the right way and collect our 3 gems with our triple gem function. Again, there we go. And you might find you can have a more involved function and shorter code, but that's just a way of optimizing it. So have a look at these, try them. There could be different solutions. Let's move on. So nesting patterns. Now, this sounds as though things are getting complicated. And there's a bit more to it, but they're no more complicated. All this really means is that we can use 2 functions together. So we've got a simple pattern here. Let's have a look. Let's go and analyze it, find what the patterns are. So let's look at it there, I think. Let's take another screenshot. So let's use our pen. And we're stood in the middle, so we need to walk forward, collect the gem, turn around, and come back. So we're back where we started, but we're facing the other way. And then, actually, we can just walk forward, collect the gem, and turn around. And then we need to add a turn because we need to do it the other way. But again, it's walk forward, turn around, and collect a gem. And same on this side. So we've got a simple pattern we can use 4 times. We just need to be facing the right way. So let's have a look. Let's delete that and let's go back to our code. Oh. We've got our code in here. Oh, let's put him there. So I'll stand behind byte. So we've already got our first function created for it. We've got our turnaround function, which is turn left and turn left. So we know now we've already got one function done for us. So there it is. And we've got a second function underneath called solve stair, but the code's empty. So we need to put something in here. So let's have a look. Let's move forward. Let's collect the gem. And then we can turn around. We've got that function already. So we don't need to do left and left. We can just turn around. And that's a nested function now. So it's a function within a function, which is fairly straightforward, really. And then I think if we just move forward again, that would do that pattern and move forward, collect the gem, turn around, and get back to where we started. So in which case, when we get to our code, we've got something fairly straightforward here. We could do solve stair once. We're facing the right way, so we can just solve the stair again. We need to then go back to the middle and turn left. We could turn left or right, because we just could go either way here. But then let's solve the stair and solve the stair. So let's try it. And that turnaround function is nested within our solve stair function. So there we go, we're turning round. And that's the first version of our function. Go collect the second gem. Back to the middle. So this is our extra line, turn left, just so we can do that crossways movement. There we go. And back to the middle. So the code is starting to look a bit more complicated because we're getting this layout and this design, but in terms of what we're actually doing, it's actually fairly simple. So let's have a look at the next one. Slotted stairways. Oh, we've got a complicated map now, so we need to think about the patterns here. But actually, if we took the stairs away, we've just got 6 gems to collect. Let's have a look. Let's see if there's any patterns. So let's take a screenshot. So with our marker pen, there we are. So we could move 1, 2, collect the gem and come back. And we're back to where we started. Actually, we'll be facing the other way. So once we're facing the other way, we can still go 1, 2, collect the gem and go back. And then if we can work out a way of going sideways, once we stood next to him, oh, look, we're going 1, 2, back. And same again here, look. Let's try this one if we can get to there. It's the same pattern, isn't it? 1, 2, back. So 1, 2, collect the gem, turn around and come back the other way. So we've got the same pattern 6 times. So this is perfect for a function because we only need to write it once then and call it 6 times. So let's have a go. So let's go back. And in fact, we've already got our first function written for us. It's already filled in. So our function has got a long name, this one, collect, gem, turn around. So we've got the beginnings of a song coming in this one, collect, gem, and turn around. Here we go. So we've got move forward, collect the gem, turn left, that's the turn around, and move forward, move forward. That takes us back to where we started from, but we're facing the other way. So let's fill in our code now for that solve the row. So we've already got collect, gem, turn around, we're back to where we started. So now, if we go in here, we can add another collect gem turn around. That solves that whole row. But if we could do that kind of side shimmy so we can do the next row as well, we can make our code really easy. So if we're back to where we started, we just need to turn right, move forward, and turn left. And that will take us just one square across from where he is now, but facing in the same direction. So we can do the next row. So let's put our code in. So solve row once, we'll do that full left-hand row. We've already moved sideways, so we can just solve the row for the next one. Then he'll move sideways again and solve the last row. So our code now actually is only 3 lines. So it's really economical. It's really optimized. We've just got 3 lines of code to run. So let's run it and let's see what happens. So there's our collect gem turnaround. There's our first function. And then in solving the row, it should do that function again. There we go, he's off down to collect that gem. And we're back to where we started. So now's our little side step. So turn right, there we go. And then it should just do the second solve row. And it's just repeated. Now we're making Byte work hard now. We've got all these steps to go up and down. So let's turn around, let's go back down the stairs. And remember, you can press that little clock to run the code quicker or to slow it down and step through the code so it highlights the lines of code as it's executing them. There we go, down to the last one. And remember, we've got that little side step, but look, we've got a square there left on the side of the map. So that should be a nice little ending point for him. So there we are, little side step. So if there was another row there, we're set to go, but there isn't. We've done 3, so we're good. We've got that one. So we have one more challenge to do. Let's have a look, the treasure hunt. Let's have a look at this map. Now we've got quite a big map here. Let's go and have a look. So what are our patterns? Let's have a look here. So one more screenshot. Oh, I'll close the map. Let's do a screenshot. There we are. And let's use a marker pen. So we can move forward, toggle the switch, turn around and go back. And actually, that repeats there, doesn't it, that way? Now, I could repeat it this way, just like we've just done, but that doesn't solve this toggle switch on the left-hand side. We've got a longer route there. So maybe actually that repeating that pattern is not going to work for that one. So maybe we've got 2 patterns, 2 repeated patterns that we need to work together. So we've got that short toggle switch there, but then we've got a long one that goes and does both switches, and we can repeat that on both sides. So we've got 2 patterns instead of 1 now that we can add in to help solve this problem. So I think that one will work there. So let's have a go. So let's move back. Now we go at our code again. So we've got no code to start with at this point now. Let's make sure we can see this. I'm going to stand behind Byte to help with our direction. So let's put our first function together then. So function, and we need to give this a name. I think I'm going to call this short toggle, because that's that short 2-step one. That's okay. And that's going to be made up of a move forward, a move forward. Let's toggle the switch. Then we need to turn around, so we'll use that turn left and turn left to turn around. And then move forward, move forward. And that should take us back, so we'll walk forward, press that button and turn around, it'll take us back to exactly where we started. And that will work for the second one, so I think that's okay for that function. Let's do our long one now. So another function, and I'm going to call this one long toggle. And let's put some code in here. So we want to, we'll turn him around separately. So we'll just have the bit assuming he's facing the right way at the moment. So let's move forward, and let's toggle that switch. And let's go move forward. So we're going right to the end and toggle that switch as well. And then we'll have a turn left to turn around. And then we need to go all the way back to the beginning. So we need to 4 move forwards should take us back there. And I think that'll be okay for that long toggle. So let's put our code in. So we want a short toggle, a short toggle. So that'll do those 2 short ones. So we'll go forward and then it'll come back and do the other one. Then we could either turn left or right, depending which side we want to do next. So let's turn left and let's do a long toggle and a long toggle. So now we've got this fairly complicated map and we've got 6 buttons to press, but we're doing all of this in 6 lines of code. Let's check it works. So there's our first function, our short toggle. Turn around and come back to the beginning. That's great, so it's facing the right way. Let's run the second short toggle. Yep, that's working. And he's going to go back to the beginning. And he should turn left, so he's facing in the right direction. There we go. So we're going to do the long toggle now. Go and press that first button. Second button, let's turn around. Go back to the middle. There we go, and we're on the home straight now. We've got the last long toggle function to run. Press that final button and turn around. And there he goes, returning back to where he started from, right at the beginning, in the middle. And there we go, we completed it. So there's some quite complex thinking in these lessons. It's not really the code, that's fairly simple once you see it written out there. But it's that being able to look at a situation, work out the patterns and how we can use those to help keep things nice and short. And analyzing that situation is a really useful skill when you're looking at coding. The same way it is when we're doing things in the real world and looking at kind of how we kind of adapt this to things that we do every day. But that idea of being able to recognize patterns and how they repeat really helps when we come to the coding. It really helps us keep it simple and optimized. I think that's it for functions at this stage, Richard.
Absolutely fantastic. So optimizing, you can see what a difference it makes, can't you, to the length of code in there. And I guess if you apply that to the real world of apps and web pages and real programming, then that will make a difference to users, won't it?
It'll make everything run a lot quicker because we're only having to work with 5 lines of code instead of maybe 25 or 50 lines of code because we're just calling it every time.
Who's your favorite transformer?
Well, it's got to be Optimus Prime, hasn't it?
Optimus Prime, indeed. It's all about optimizing. So Optimus Prime, fabulous. And we can see just over this few short sessions that we've done so far that we're really starting to explore some of these computational thinking concepts and applying logic to solving puzzles, and it all looks like good fun. Excellent, excellent. So if you would like to know more about Everyone Can Code, if you've got the iPads in your setting, then you've already got the hardware that you need. Just go point your camera at that QR code or visit the website. Just do a search for Everyone Can Code. And that page will take you to Apple's summary of the program. About halfway down that page, there's a big PDF file that sort of goes into real detail about how many hours of activity there are at different age groups. And it's just a fabulous resource as we're seeing, thanks to David. There are plenty of other Apple resources for schools, and you can learn all about those by joining the Apple Teacher program. Apple Teacher is free professional learning from Apple. You just log in with your Apple ID. So the top QR code there will take you to an overview of the program, and the second one there is the all-important sign-up page. So just sign in with your Apple ID, identify yourself as a teacher, start working through those modules, and you will earn the Apple Teacher badge, which you can print out, stick on your wall, or pop that onto your social media avatar, and let the world know that you've taken the time to have a look at Apple Teacher. Finally, if you're a school looking to take your computing to the next level, we have an MCC MyLearn computing toolkit, which will help you do that. So this kit consists of 16 iPads, so that's one for teacher and one between 2 for a class of 30, 15 Sphero robots, that's the cricket ball size robot there, and they have a little LED screen, you can program them, they move around, run around the classroom, really bring it off the screen and bring it to life. And they also now have the Sphero rover, so we also include a 5-pack, a classroom pack of 5 rover robots. That's the tracked robot you see at the top half of the screen there. And they're good fun. You can take them outside and get them out into the playground and program them using either Sphero's own app on your iPad or with the Swift Playgrounds app that we've looked at. We're going to look at this in more detail next time around when we're going to be joined by a special guest, Darren from Sphero. So do come back for that one. That'll be this Thursday at 4 o'clock. We look forward to seeing you then. Hope you've enjoyed this one. I know I've certainly learned a lot about optimizing. That's so important, isn't it? So we will see you. We're going to optimize our time. I think we're bang on 1/2 past. So job done. And we'll see you next time. Thanks for joining us.